In the deepest parts of the ocean, where sunlight has never reached and pressure can crush steel, a silent contest has shaped the balance of power for generations. It is a war without explosions, a war without witnesses, a war where the most decisive weapon is not firepower, but sound. For more than 70 years, the U.S. Navy has mastered the art of tracking enemy submarines without ever being seen. Not by chasing them, not by attacking them, but by listening, patiently, methodically, relentlessly. This invisible struggle has determined nuclear strategy, prevented wars, and kept entire continents safe, without the public ever knowing it was happening. To understand how the U.S. Navy learned to track what it cannot see, we must return to a moment when submarines first terrified the world. During World War II, submarines were loud, slow, and vulnerable when submerged. They relied on diesel engines, which forced them to surface regularly. Allied forces countered them with sonar, depth charges, and aircraft. Detection was imperfect, but it worked most of the time. Then came the nuclear age. When nuclear-powered submarines entered service in the 1950s, everything changed overnight. These vessels no longer needed to surface. They could remain submerged for months, crossing entire oceans in silence. Even more alarming, they could carry nuclear missiles capable of annihilating cities. For the first time in history, a single submarine, unseen and undetected, could decide the outcome of a war. American naval planners understood the danger immediately. If enemy submarines could move freely beneath the oceans, deterrence would collapse. There would be no warning, no second chance. The ocean had become the ultimate hiding place. But the ocean has a weakness. Sound travels farther underwater than almost anywhere else on Earth. Temperature layers, salinity, and pressure bend acoustic waves, allowing noise to propagate across hundreds, sometimes thousands of miles. A submarine does not need to be close to be heard. This realization gave birth to one of the most secretive and ambitious surveillance programs in military history, SOSUS, the Sound Surveillance System. Built quietly during the early Cold War, SOSUS consisted of vast arrays of hydrophones laid across the seabed in strategic choke points: the Greenland-Iceland-UK gap, the Pacific approaches to Asia, and the deep channels submarines were forced to pass through. These sensors did not emit sound, they listened. Every propeller blade, every turbine vibration, every mechanical resonance created a unique acoustic fingerprint. Over time, American analysts built libraries of these signatures. Entire classes of submarines could be identified by sound alone. For Soviet submarines leaving port, the ocean was no longer empty, it was monitored. Operators stationed in windowless facilities listened around the clock. They watched scrolling sonar displays, translating abstract patterns into operational intelligence. A faint rhythmic hum could mean a ballistic missile submarine. A subtle harmonic shift could indicate a course change. The submarines never knew they were detected. By the 1960s, the United States often knew when Soviet submarines deployed and where they went almost immediately. Some patrols were tracked from start to finish without a single visual contact. But fixed sensors had limits. As submarines grew quieter, the Navy needed mobile hunters that could listen even more carefully. That hunter became the submarine itself. American attack submarines were redesigned around passive sonar, systems that never reveal their presence. Long towed arrays, sometimes stretching hundreds of meters, allowed submarines to listen far beyond their own noise. These arrays transformed the submarine into an underwater intelligence platform. Instead of charging toward a target, U.S. submarines drifted silently, letting the enemy reveal themselves through motion alone. Speed became a liability. Silence became survival. Inside the sonar rooms, sailors endured hours of mental strain. Identifying a submarine was not dramatic, it was incremental. A contact might take hours to confirm, days to classify, weeks to follow, and yet mistakes were unforgivable. During the Cold War, U.S. submarines sometimes followed Soviet ballistic missile submarines at close range for entire patrols. The goal was not to attack, but to ensure that if war ever came, those submarines could be neutralized immediately. This shadowing was dangerous. Two nuclear-armed vessels moving silently in close proximity, separated by sound and trust in training. Above the surface, aviation added another layer to the unseen net. Maritime patrol aircraft dropped sonobuoys, small floating sensors that deployed microphones deep underwater. Dozens or even hundreds could be released in carefully designed patterns, forming temporary acoustic fences. The aircraft never needed to spot the submarine. They listened, relayed data, and adjusted the grid as the target moved. It was underwater chess played at hundreds of miles per hour. As computing power advanced, information from seabed sensors, submarines, ships, and aircraft began to merge. Intelligence centers fused acoustic data with satellite tracking, oceanographic models, and behavioral analysis. Submarine commanders were no longer guessing, they were predicting. By the late Cold War, the strategic reality was sobering for America's adversaries. Submarines were still dangerous, but they were no longer invincible. Stealth was conditional, silence was relative. This realization shaped nuclear doctrine itself. Submarines were pushed deeper, quieter, more isolated. Their crews trained to minimize every possible sound, even adjusting how tools were handled, how doors were closed, how water flowed through pipes. The ocean became a test of discipline. After the Cold War, many believed this silent struggle would fade. It did not. Today, anti-submarine warfare is entering a new era. Artificial intelligence now analyzes acoustic data at speeds no human team could match. Systems search not just for noise, but for patterns, anomalies, and absences. Modern submarines are quieter than ever, but the ocean is also more crowded. Commercial shipping, undersea cables, and environmental sensors create a dense acoustic environment, one that can be exploited by those who understand it best. The principle remains unchanged: detection without detection. No active sonar pings, no warning, no confrontation. Just knowledge. And knowledge in warfare is power. The greatest achievement of the U.S. Navy's submarine tracking system is not technological dominance, it's deterrence. Wars that never happened, missiles that never were launched, decisions altered because someone knew they were not alone beneath the waves. In a world obsessed with visibility, the most decisive military advantage remains invisible. Somewhere in the darkness of the ocean, a submarine moves quietly, confident in its stealth. And somewhere else, someone is listening. Because in the silent war beneath the sea, the side that hears first never needs to be seen at all.